Hi, so today we will see this minimum cost to move chips to the same location. And in this problem, we are given the positions of the chips. It's 1, 2, 3, and we have to move all the chips at a single location. Now, the movements are we have two, every chip can have two possible movements. Either it can move one step or it can move two steps. If it moves two steps, the cost is 0, but if it moves one step, that is if we change 1 to 2, that is move this chip from 1 to 2, the cost is 1, and if we move this chip 1 to 3, then the cost is 0. And we have to move all these chips at any of the single position, and the cost should be the minimum. An example is given here for our understanding that this the three chips are here and the two chips are at this position, and to move all the chips at a single position, that is at the 2, the minimum cost is 2. We could have moved all the rest chips to here, but that would be the maximum. Now how to solve it? First uh, let's learn it with the help of a whiteboard. So we have this 10 positions, it's random positions, and let's say that we have one chip at here at one position, two chips at the third location. At the position 3 we have 3. At the position 4 we have 3 chips. We don't have any chips for 5, 6, 7, 8, 9. We just have this many chips. So how can we solve this? We just saw that if I move this chip from here 1 to 3 or 3 to 1, the cost would be 0. So the thing is I would do is I would move this chip and place it over here. The cost would be 0. Now I have to move this all these 3 chips on top of this, and the cost for that is 1. So if I cancel this and place it over here, the cost is 1. If I do it for this and place these chips over here, then the cost would be 3. This is the minimum cost that we have. Let's code now, since you understand how it is working. Okay, and our input is like this. We are given the positions, and at every position there is a chip. Let's first consider how many chips are odd, because we are changing chips from 1 to 3 and 5 and 7 and 2, 4, 0, 8. So there is a pattern. That is why we are just using odd. Let us calculate how many odd chips we have and how many even chips we have. Okay. For num in position, okay, if number here 2 equal to 0, we increase even plus 1, else odd plus equal to 1. Now let us print this. Okay, so here this is the input 1, 2 and 3, which is same as this, and we have one even, that is this is even, and 2 odd. So we can move these two freely without any cost. It is from here to here and here to here. But to move this, we are going to use a cost. And what do we have to solve? The minimum cost. So we have to select the minimum from both of these. So let us just print minimum of odd and even. And output is 1. Expected was also 1. So we can just return it. Okay, first let us check what are the constraints, if there are any. Okay, there are no such constraints. Let's run this. Nice, the test case is passed. Now let us submit this. And it works fine, perfectly. So this was an easy one. You just have to use the odd and even, but the problem, this seems a little hard because it says that from 1 to 3 you can write some big logics and then it might fail. But the thing is, it is just about even and odd positions. There's nothing else. It is very easy and simple. So if you have any doubts, just write it in the comment and I will respond to you as soon as possible. And if you have not subscribed, please subscribe.